ICQCC. Magandang po. Bye-bye.
Welcome, ladies and gentlemen. I'm Chang Hyun-ju from Find the Circle.
Samsung Electronics Mobile Business Division was established in October 1986, and 529 workers are working to build a world-leading manufacturing site. Our main products are Galaxy S, Galaxy Note, Galaxy Gear, and so on.
We ranked number 7 in 2016 global brand, and we are doing our best with the vision to be the number 1 mobile innovator who is loved by customer with best products and service.
Our sector is in charge of the S&D department. There are 8 people in our finance sector to organize that. We are in charge of production and quality management.
Let me introduce the process. In Galaxy S6 manufacturing process, there are storage components, assembly, DBA, mainline, and shipment. Our sector is in charge of assembly.
S&D is the process of producing electronics, that is where the components are mounted or placed directly on the surface of PCB. There are 7 steps in S&D process from router to router. What we are going to improve is the dispensing process. Dispensing process is consisting of supply, cleaning cost, dispensing thin liquid for heating emission, attaching the film to prevent electromagnetic wave, testing the film, and releasing PCB out.
This is the topic selection process. When the leader asks us to submit agendas, we gather them and perform pre-evaluation and then select 4 of them. We review comparability from the perspective of department and circle. As a result, we've chosen to decrease the defect rate in dispensing process through improvements for Galaxy S6.
Next, this is the background to the topic. In accordance with the world mobile market growth, our Galaxy S6 market share of production had been constantly increasing, and its defect rate had been also increasing. According to our research of defect rate, it's over 1201 ppm compared to the S&D department curve. And we check the defect rate in S&D is not seasonal. Furthermore, dispensing defect rate accounts for 66.3% in S&D process. To achieve the S&D department curve, 1800 ppm. We need to decrease 1201 ppm in dispensing process. If we achieve the curve, it is expected to save about 120,000 US dollars. That's why we chose this topic, and our members participated in this project and set the defect schedule together.
Next is figuring out the current situation. After checking the picture of the defect rate, there was no issues. But we needed urgent improvements because the defect rate exceeded the division's initial goal. As a result of analyzing the defect rate, dispensing film and attaching film accounts for 88.6%. So we chose it as our major management item.
Would you please wait for a moment? Let me introduce dispensing pin and link. If a cell phone carries an operational management alarm, the memory emits heat. So we dispense the thin liquid on the memory to absorb the heat, and to prevent electromagnetic wave emission, we attach the link.
As a result of analyzing the defect rate of dispensing tin, exceed dispensing, irregular dispensing, and low tin liquid defect accounts for 89.2%. We collected data from process management in GMS system, and we analyzed it using ultra-high-speed camera, viscosity meter, and electron microscope.
Here is a question. What is the exceed dispense? It just tells us that the height of dispensing tip is higher than the standard level. On average, it is 0.872 millimeter. It does meet the standard level. So, we did correlation analysis to check the thickness depending on liquid viscosity. The result says there is a strong negative correlation, and we checked X bar R chart of liquid viscosity. It shifted toward the lower limit.
What is the irregular dispensing? The length of dispensing is longer than the standards. On average, in 13.31 millimeters, it shifted toward the higher limit.
What is no thin liquid defect? There is no thin liquid on the memory after dispensing. We verified the form of aberration in the histogram of air pressure.
Please take a look at the defect rate of attaching film. Shift, fold, and lift defects accounts for 89.7%. Shift defect occurs whenever picker pen picks up the film out of supplying position. Process capability analysis says the CPK is 1.14, which means we need to make modifications.
What is the fold defect? It just tells that the film is not flat and folded. When the film is applied, we confirm fold phenomenon at the picker position. What is lift defect? It just tells that the film comes off on shielded plane. Process capability analysis says the CPU is 1.19, which means we need to make modification.
Next is cause analysis. Using the characteristic diagram, we chose the supplying motor pen issue and cooling pen issue for exceed dispensing. For irregular dispensing, we selected accumulation time, low air pressure, and low storage bracket for syringe. Also, for no thin liquid defect, we chose the gap between the tip syringe and supply tube, fragile packing material, fixed word loosening, and PDA for PG issue.
For shift defect, we selected filling color difference and supplying issue. For fold defect, the contact area of filling guide is too big. Lastly, for lift defect, we selected the collision issue between the materials and summarized into major cost distribution diagram.
Next is setting code. In order to achieve the 789 ppm in dispensing process, we set our goals to 361 ppm in dispensing and 205 ppm in attaching fluid. Furthermore, in order to solve the final cost, we established the distribution diagram by selecting 5 major implementations and 6 immediate improvements, and then set the detailed schedule plan. For immediate improvements, we completed 5 cases, including installation of storage bracket, and we tested to register them as standards.
Next is the measure implementation. We are now going to present the 3 major improvements.
First, major implementation is set the optimal value for pressure and supplying time. The problem was low air and bucket pressure caused the irregular dispensing defect. The result of surface response design analysis of two-factor two-level says the experiment is valid. So finally, we found the optimal value 0.93 seconds for bucket time and 9.7 kilopascal for bucket pressure by using control plot and response optimization tool. After implementing the measures, according to the process capability analysis, CPK improved from 1.1 to 1.72. We achieved a 125.1% compared to the defect rate goal. So we retested to amend working instruction standards. Second major implementation is change the type of the supply tube. Air leaks due to the gap between the tip syringe and supply tube caused the low tip liquid defect. So we used the Q metrics to improve it. As a result, we decided to add fluting on the supply tube. But wait, Miss Swan, where did you get this great idea?
Yes, when I plug a barcode into an electronic outlet, the idea struck me. If I add routing a supply tube, we can assemble it easily without twisting.
Great. After improvements, air pressure histogram is proper and XBAR chart is also under control. We achieved a 119.9% compared to the defect rate scores, so we requested to amend equipment standards. Third, major implementation is change the shape of the filling guide. The problem was the film was attached on the filling guide and it caused the hole defect. So we suggested 4 types of filling guide to improve. As a result, we've chosen comb-type filling guide as optimal shape. After improvements, the film wasn't attached to the filling guide and there was no hole defect. We achieved a 113.9% compared to the defect rate scores, so we requested to amend equipment standards.
Next, result analysis. After checking the chart of dispensing defect rate compared to before the implementation, 1372 pipette has reduced. As a result, we achieved our goal by 150.4% in dispensing team, 120.5% in offensive clean, and 117.2% in dispensing process.
As a tangible effect, we can save about $200,000 from saving cost minus investment cost. As an intangible effect, we can decrease the work fatigue, we can increase the work efficiency. As a ripple effect, we apply improvements to China and Vietnam branches, we can save about $750,000.
Next is standardization. We register 7 case equipment standard, 3 case work standard, and 1 case of new material code.
Next is follower control. As a result of checking the picture, on average, the defect rate is 525 ppm in dispensing process, which is very stable figures. Also, we assign a person to manage daily checklist.
Next is self-reflection and future plan. Through active evaluation by step, we established improvements by assessing what we are good at and what we need to improve in the future. As a future plan, there is a new technology training and workshop about automation process, and we expect to develop our circle through this activity. Nowadays, our circle is in middle of major implementation, aiming reduce the time lost by improving equipment condition.
Mankind spent a million years with light from nature. In the meantime, Thomas Edison invented metal filament lamps. This effort still impact people's lives.
However, there are many questions regarding the cost of this invention. Are there better ways to improve? Are there better ways to take advantage of this ingenuity? Through trial and errors, they succeeded.
Our Finder Circle will continuously step forward for innovative products.
We will assess the change with the question and solve all problems in manufacturing side.
Thank you.
Right. Looks like Lean Six Sigma continuous improvement is already mature in your organization in Samsung. So it looks like it's already embedded in your culture, and that's commendable. I was impressed in terms of the usage in the different statistical tools when you used your XBAR chart and doing the process capability, checking process capability index and all of that stuff. I'm pretty impressed with the presentation, even on the results. Going through the entire thing step by step, so real nice. Thank you.
In the process of collecting data collection, okay, and about the result, have you compared with your competitors' performance?
Actually, we have a unique system. It is called the GMES. If the defect occurs, the data will be updated on the system. So we can get the data from it very easily. So we control all things.
So how far is it from the industry standard?
Yeah, we adopt this system because about 7 years ago. So we use that one very smart system.
Is S6 still a very hot commodity in the market now?
No, these days we are producing the Galaxy S8 and the Galaxy Note 8. So that is main products, but we are producing the Galaxy S6 also.
Yeah, but the findings that you made on the S6 in the dispensing process can be also used in your S8.
Yeah, it's similar, but we improve it. So at that time, 2 years ago, we dispensed the chip kit, but these days we combine the film and dispensing thing. So we reduce the time, production time.
Just curious, by the way, what's the main defect of the Note 7?
Yeah, it's a little bit embarrassing, but people from this February we learned a lot. So we prepare for the new models. So actually we do not make that same mistake.
Thank you.
Thank you.